Let's come to the last topic of this section, the first chapter. So, we have already studied our 9th class regarding rational number. If a rational number is given in front of you, how can you make that into terminating decimal and non-terminating repeating decimal? In 9th class, we use the word recurring, right? That means repeating itself. So, here very clearly we are using that same word, repeating, okay? So we can say that if you are taking the decimal expansion of any rational number, if a rational number is given for you, and if you are trying to find out the decimal expansion of that given rational number, it is of two types. What are they? Number one, it can be terminating decimal, means after the decimal place, after some particular numbers, it will terminate, means it will stop. Means you will get the remainder as a 0. That's the meaning. Okay. In some other cases, you have seen that it is non-terminating but repeating. Means after a particular digits, it keeps on repeating. The number keeps on repeating. So, if you are finding the decimal expansion of any rational number, they are of two types. So, in 9th class, if we want to find it out, how did we done there? What was the thing which we are doing there? We used to divide it, right? If 1 by 3 is given, we will divide 1 by 3. We will divide 1 by using 3, and then we will start going further, and then we will find the decimal expansion. If 25 by 4 is given, you will divide 25 by 4, and you will find the answer for that one, right? That is what we were doing in our 9th class. But in 10th class, we are going to study a new method. That means there is no need of actually dividing any number, whether to understand that the decimal expansion of the given rational number is terminating or whether it is non-terminating repeating. There is no need to actually divide it totally and see it. That means the wait is over. There is no need to wait that much. There is no need to wait. Then how can we do this one? Just by seeing the denominator part. Just by factorizing the denominator part. Okay. So how can we do this one? That's what we are going to study today. So here goes it. If a rational number is given to you, if a rational number is given for you, what you have to check out the denominator part only. Whatever the numerator, it doesn't matter. You just check out the denominator part. And one thing should be important, the given fraction should be of the simplest form. I repeat, the given fraction should be of the simplest form. If it is not of the simplest form, you have to bring that into a simplest form. That means the numbers should be coprimes. Okay, for any coprimes, if a fraction is given, bring it to the simplest form. That means bring it to a coprime form, so that they will be having only a common factor, that is 1. So bring it to the simplest form, and in the simplest form, check out the denominator. That's the point. In a simplest form, you have to check out the denominator. If you are checking out the denominator, one thing should be noticed, because if, see, in 9th class we have studied about this one. If you are taking any rational number, or simply choose some of the rational numbers right now, simply imagine some rational numbers in your mind and just try writing that one, copy them to your notebooks and just try it. You can understand one thing, the denominator part of any rational number will be a multiple of 2, or it will be a multiple of 5, or it will be a multiple of 2 and 5 alone. That means it can be expressed in our language. If we are saying in our language, in our mathematical language, if we are saying, we will say like this, the denominator part of the simplest fractional form, that means a simplest rational number, the denominator part of a simple rational number, it should be a product of the powers of 2 or the powers of 5 or the powers of 2 and 5. Clear? So if you're checking all the rational numbers, you can find this uniqueness. So that is the thing which we are going to implement in this question, so as to solve and find it out whether the given rational number is terminating or it is non-terminating but repeating. That means there is no need to divide. Okay, so let us get into the question, and now you will, when you are starting doing this question, you will get an idea for what I said right now. Okay, so let's start with the very first question. Here there are 10 questions given in front of you, and see the heading of the question. What is the heading of the question? Without actual long division. Without actual long means you should not divide them actually. You should not divide them and check it out. Without actual division, without actual long division, you have to classify these given rational numbers as the terminating decimal expansion or non-terminating repeating decimal expansion. So you have to say whether it is going to terminate or whether it is going to terminate and repeat. There are only two cases, okay? In these two cases, any one will be the answer. So here, let us go with the first question. What is the first question? 13 divided by 3125. So here 13 divided by 3125. So what did I say first? I told you, initially you have to check it whether the given thing is of the simplest form. Is it of the simplest form? Yes, it is, because 13 is already a prime number and 3125 definitely it is not going to be divided by 13. How did you got that it is not going to divide it by 13? Already it is divisible by 5, right? Because the last number is 5. So anyhow on the numerator part there is no 5 or there is no multiples of 5 definitely. So we cannot cut it short. So this is the simplest form. So now choose the denominator part. What is the denominator part? 3125. Just divide it side, means factorize it and see. While factorizing, what did you got? You got it as 5 raised to the power 5, right? 5 multiplied by 5 multiplied by 5 multiplied by 5 multiplied by 5 means 5. When 5 times you are multiplying, you will get the number 3125, isn't it? So the denominator part can be expressed as in the form of what? 5 raised to the power m. I told you, if any decimal, if you are taking a denominator part of a fraction number, if it can be expressed in the form 2 raised to m into 5 raised to n, or simply we can say 2 raised to m or 5 raised to m, then we can say it is terminating. So what about here? The denominator part can be, it is expressed right now as the form of what? 5 to the power of something, right? Here it is 5 to the power of 5, 5 raised to the power of 5. That means it is expressed in the powers of 5 alone. So we will write here 3125 is equal to how much? 5 raised to the power 5. That means, therefore, the denominator can be expressed in the form 5 raised to m. Hence, this number is a terminating decimal. Means this rational number is a terminating decimal. If you're taking the decimal expansion of this one, it's going to terminate after some numbers. Okay, what about the next one? Question number 2. 17 by 8. So 17 is a prime number, 8 is an even number, so it's in the simplest form itself. Taking the denominator part. What is the denominator part here? It is 8. How can we express 8 as the powers of primes? It's 2 raised to the power of 3. 2 into 2 into 2 is 8, right? So 2 raised to 3, 2 cube is 3. So here also you can express the denominator part as the power of 2. That means you will write here the denominator can be expressed in 2 raised to m. Therefore, this rational number is terminating decimal. It's going to terminate. Okay. Next one. Next question. 64 divided by 455. So 64 divided by 455. 64 is an even number. 455 is an odd number. Definitely there will be, we cannot cancel it. It's in the simplest form itself. Now let us factorize 455. Let us bring it to the product of primes. While bringing to the product of primes, what it become? 455 is equal to, check it out, 5 into 7 into 13, right? 5 into 7 into 13. What does it mean? The denominator part is not of the form 2 raised to m and 5 raised to n, right? It's having much more. So it's not of the general form 2 raised to m and 5 raised to n. It's of, here you can see 7 and 13 are also included in the denominator. Therefore, this decimal expansion will be non-terminating repeating decimal. Clear? It's non-terminating, it's repeating. because it's not of the form 2 raised to m into 5 raised to n. Clear? Next question. Question number 4. 15 divided by 1600. 15 divided by 1600. Let us check it out. What about 1600? If you are bringing that 1600 as the product of primes, if you're bringing it in the product of primes, what you will get? 2 raised to 6 into 5 square. 2 raised to 6 into 5 square. Now tell me, is it terminating or is it going to non-terminate repeating? Definitely it's going to terminate. Why? Because it's of the form 2 raised to m into 5 raised to n. So we will write like this. This denominator is of the form 2 raised to m into 5 raised to n. Therefore, this rational number will be a terminating decimal. It will be a terminating. It means if you are finding that decimal, definitely it is going to terminate. Next question. Question number 5. 29 divided by 343. So let us factorize 343 as the product of primes. What you got? See here, 7 into 7 into 7, right? What does it mean? 7 cube, right? So tell me whether it is terminating or whether it is non-terminating repeating. It's definitely non-terminating repeating. Why? Because we can say this is not of the form. This is not of the form 2 raised to m into 5 raised to n. Because here you can see there is no 2, there is no 5. Right? It's only about 7. So we will say that this is not going to terminate, but it's going to non-terminate and repeat. So we will say this decimal expansion is non-terminating, repeating decimal. Next question, question number 6. 23 divided by 2 cube into 5 square. It's very easy because there is no need to factorize and make it into the product of primes because already the denominator part itself is given as the product of primes. So let us choose it very fast. Tell me, 2 cube into 5 square. It is of the form 2 raised to m into 5 raised to n, right? Both of them are expressed in the powers of 2 and 5 alone. So we can say this decimal expansion is going to terminate. It's a terminating decimal expansion. Question number 7. See here, 129 divided by, see the denominator part, 2 square into 5 raised to 7 into 7 raised to 5. What about this one? Check out the denominator part. It's very clear, right? What is clear? You can see that there is not only 5 and 2, but also you can see there is a 7 also. 7 is also included in the denominator part. And what if 7 comes? We can say it's not going to terminate because we want only of 2 and 5. Then only we will say it is terminating. Here very clearly it is given 7. So we will say here as 7 is included in the denominator part and it is not of the form 2 raised to m into 5 raised to n. Therefore, this decimal expansion is non-terminating repeating decimal. Clear? Next one. 6 divided by 15. Okay, 6 divided by 15. It's not of the simplest form, right? Because 6 can be expressed as 2 into 3. What about 15? It can be expressed as 3 into 5. 3 into 5. Now, on the numerator and denominator, 3 is common. You can cancel them. Now, the simplest form becomes 2 by 5. It became 2 by 5. Now, tell me. The denominator part is 5 alone. I told you initially, if it is 2 alone also it's okay. If it is 5 alone also it's okay. And if it is a combination of 2 and 5, then also we will say it is a terminating. So here it is 5 alone. So we can say this decimal is also going to terminate. See, it's a typical question. You know why? Because see here, normally if you factorize, if you are simply without making into simple fractions, see, there are chances to make a mistake while doing this particular, even though the number is so small, 6 by 15, it's a small digit number, right? It's very familiar digits also. You are very familiar with 6 and 15. It's very small numbers. But here, there is a possibility that students can make a mistake. You know where? If you are just focusing on the denominator, let us focus on the denominator. Here the denominator is 15. Okay, so how can you express 15? 3 into 5. So normally those who are taking only that 15, they will write denominator 15 is equal to 3 into 5. So 3 is also included in the denominator. So it is not of the form 2 raised to m into 5 raised to m. Then they will conclude, they will come to the conclusion that it is non-terminating repeating, but it's wrong. Right? It's wrong. That's why I tell you, make sure that the given fraction or the given rational number is of the simplest form. If it is not of the simplest form, you have to bring it to the simplest form, then only start the simplification. Clear? So that's why here we simplified as 2 into 3 and here 3 into 5 and 2 and 3 and 3 get cancelled. Finally, we got 2 by 5 and now we can say that yeah, this is going to terminate. So that's why I told you, you must be very careful while dealing with these typical types of questions because there are some tricky questions in between also and we have to understand. So that is the foundation, that's the base which I told you that first of all, the given rational number should be of the simplest form. If it is not of the simplest form, you are supposed to make it to a simplest form, then only start factorizing the denominator part as the product of primes. Then only come to the conclusion, or else you will get a wrong answer. Right now, just as I told, that may lead you to the wrong way and you will get the wrong answer. You will lose the marks and you may be thinking that you have done it right, but that will be a wrong one. Hope you understood. Next question also, let us see. Next question also, it's almost like this. See, 35 divided by 50. It is not of the simplest form. You know, 35 and 50, both of them comes in the table of 5. So you can factorize them again. So 35 can be expressed as 5 multiplied by 7. 5 into 7. What about 50? You can write it as 5 into 10. Right? Or you can write 5 square into 2. If you are expressing as the product of primes, which we studied in the previous section. Expressing as the product of primes, you can write 2 into 5 square. Now tell me, in the top and bottom, you can see 5 is common, you can cancel the 5. So now here, the denominator part comes to 10 only, 10. That means, here the denominator is 10. Now how can you express 10? 10 is equal to 2 into 5. You will write 2 into 5. Now tell me, is it terminating or is it non-terminating? It's terminating. Why? Because it's only of the form 2 raised to m into 5 raised to n. Here m and n are 1 itself. Even though we wrote simply 2, it actually means that there is a power of 1, 2 raised to 1. Okay, like that. Next, the final question of this section. What is it? 77 divided by 210. Okay, 77 can be expressed as 7 into 11. Right? What about 210? It can be expressed as 7 into 30. 30. So now you can cancel the 7 from top and bottom. You can cancel the 7 from top and bottom, right? What will you get? Now you got the simplest fraction, that is 11 divided by 30. 11 by 30. So now what about this 30? 30 can be expressed as 2 into 3 into 5. 2 into 3 into 5. Now tell me whether it is going to terminate. Absolutely no. Why? In between 2 and 5, you can say there is one 3, which is not supposed to be there for a terminating decimal, right? So here, as 3 is included in the denominator part, what will we conclude? We will say that the decimal expansion of 77 divided by 210 is a non-terminating repeating decimal. Hope you understood these sections. So this is how you have to understand a fraction or a rational number without dividing, how to conclude whether it is going to terminate or whether it is going to it is of the form non-terminating repeating decimal. This is how we have to do. In 9th class, we have to do long divisions, but here in the title itself, it is mentioned that not to divide by long division method. If in case you have divided there on the side and if you're checking out, definitely you will miss the marks. You will not get the allotted marks. So never do like that. Only check the denominator part and make sure that it is of the form of 2 and 5. Let me ask you a simple question. A simple question. What if a question came like this? 7 divided by 1. 7 divided by 1 means simply 7. What will you say? If the denominator part is 1, what does it mean? Is it of the form 2 raised to m into 5 raised to n? Normally we will think no. right? We will say big no, because 1 cannot be expressed as the terms of 2 and 5. That's what going into our mind, right? But it's absolutely wrong, because 1 can be expressed as the powers of 2 and 5. How? Because any number raised to the power of 0 is 1. Any number raised to the power of 0 is 1. So you can write 1 as 1 is equal to 2 raised to 0 into 5 raised to 0. That means you can express that 1 as the powers of 2 and 5 itself. So definitely that's terminating. Already you know that 2 means 2 itself. It's a constant number. It's terminated already. There's nothing to deal with. But simply I just told you, keep this in your mind, that if any number raised to the power 0, then the value of that number is 1. Clear? So this is how we have to understand the decimal expansion of a rational number, whether it is going to terminate or whether it is of the form non-terminating repeating.